Let us do some mathematical tutorial for that the spring mass system, that things, so that it will be very clear to you. Let us consider the first problem. It is said that a particle oscillates with a simple harmonic motion, so that its displacement varies according to the expression of x is equal to a particle in simple harmonic motion. Its displacement is the form of equation 8 cos omega, instead of omega I said k is cos 3t plus pi by 4. Okay. Now, if I say where x is in centimeter, x is in cm, centimeter. Now, and t is in, x is in centimeter and t is in second. Okay. Now, if I say find out the displacement or displacement of particle at t equal to 0. What should be the displacement of the particle at t equal to 0? So, if you remember, this x is in the form of a cos omega t plus phi. Okay? X is in the form of x a cos omega t plus phi. So, what is a? What is the value of a? A is nothing but a 8. What is omega? Nothing but a 3. What is phi? Is nothing but a pi by 4. Now, if I say at t equal to 0, what should be the displacement? Let x 0 is equal to 8 cos t equal to 0. So, it is cos pi by 4. 8 cos pi by 4, you know that pi by 4 cos pi by 4 value multiply by 8 centimeter. Now, if I ask what is the velocity of that oscillation? So, velocity is nothing but a dx dt. So, it is nothing but a, if I take the dx dt minus a omega sin omega t plus phi. So, what is a? Is nothing but a 8. What is omega? Is nothing but a 3 sin t is equal to 0 pi by. Okay. Now, if I say what is the acceleration of this oscillation? A. Acceleration is nothing but a d2x by dt square. So, it is nothing but a minus a omega square cos omega t plus phi. So, again a is nothing but a 8, omega is nothing but a 3 square and cos is nothing but a cos pi by 4 at t equal to 0. Then, if I say find out the period and amplitude of the motion, if I said find out the period of the motion, what is the period of the motion? What is the period of the motion? So, what is omega? It is nothing but a 3. Omega is 3. Now, what is f? Omega is nothing but a 2 pi f. Then what is f? Is nothing but a omega by 2 pi. So, it is 3 by 2 pi. Okay. So, that way I can find out any parameter for that things. Now, let us consider a problem which is little bit of complex. Just read the problem from the slides. See the slide first. Consider a tractor driving across a field that has an undulation at regular interval. The distance between the bump is about 2.1 meter. Because of the safety reason, the tractor does not have any suspension system, but the driver's seat is attached to a spring to absorb some shock as the tractor moves above the rough ground. Assume the spring constant of the driver's seat spring is 2 into 10 to the power 4 Newton meter per second. Okay. Spring constant, so Newton per meter, and the mass of the seat is 50 kg and the mass of the driver is 70 kg, the tractor is driven at 60 km per hour over the undulation, will an accident occur? If I say, will an accident occur? So, after reading that statement of the problem, what you understand? That there is a tractor which move across a road or a field which has a bump, one bump, another bump and another bump is there, and the bump distance between the two bumps is nothing but a 2.1 meter. Okay. Now, tractor has a seat has a spring, and over the seat I have a mass. So, the system is nothing but a mass spring. Okay. So, spring constant is 2 into 10 to the power 4 Newton per meter, and mass is equivalent to, what is the mass? Seat mass plus the driver mass, 50 plus 70 is equal to 120 kg. Okay. Now, I said, will an accident occur? So, after you know the mechanical oscillation, what you will say? That if the tractor seat is resonate with the force which is received from that bump, then the driver will be uprooted from the seat, because if the system is resonate, maximum power transfer will be happen. So, driver cannot hold the seat. Okay. So, accident will be occur. So, only I have to find out whether this spring mass system will be resonate or not due to the vertical force. Where the vertical force will be happen? Because of the speed 60 kilometer per second per hour, the bump will pass. So, the interval of the bump is 2.1 meters. So, the tractor will get a vertical force with the frequency in that interval. So, what is the frequency of that tractor? So, if it is del x and if the speed is let us v, then what is the interval between the time interval between the bump is the frequency of that vertical force, because every bump provide a vertical force to the tractor. So, the frequency of that force is nothing but an interval time taken to cause this interval. So, I can say del t is nothing but a del x divided by v. What is del x? 2.1 meter. What is v? 60 kilometer. So, 60, if I want to convert it meter, 60 into 1000 divided by 3600. So, if I cut it, so it is nothing but 100 by 6. Okay. So, how much it will come? You can calculate that value, 100 or yes, 100 by 6, 100 by 6 or 100 by 6 will come. So, you can calculate. Then I get the delta t. Once I get the delta t, put the x value and the v value 100 by 6, then I get the delta t. So, if the time interval is delta t, then what is the frequency? Frequency is nothing but a 1 by delta t. I will not completely do that problem, you have to do it. So, f is nothing but a 1 by delta t. So, this is the frequency of the applied force F, frequency of the applied force F. If the applied force frequency omega is equal to omega 0, then the resonance will be happened. So, what is omega 0? Omega 0 is nothing but a root over of s by m. So, what is spring constant? You know spring constant 2 into 10 to the power 4 Newton per meter divided by total m is equal to 70. So, you get the omega 0. Now, you have to see whether the omega is close to omega 0 or not. If it is close to omega 0, the accident will be happen. If it is not, accident will not happen. Okay. that is why when you cross a bump, regular bump, you see there is a speed limit mentioned in the roadside. Please drive with a 30 km/h. It is not that to reduce your speed for safety. Once you cross the bump, you get a vertical oscillation. If that oscillation does not support your suspension system of the car, your car will be broke down or maximum power transfer will happen, car suspension system may be damaged or a accident may occur. So, that is why that this problem I have given. So, this the practical relationship between the spring mass system to the real life problem. So, if you know the spring mass system, then okay, you can easily explain the real life problem of different situation. Okay? So, this is the one of the problem. Similarly, let us I give another problem, that is draw the mechanical equivalence of circuit is not correctly drawn in slides. I will draw it in the board. Let us I have an electrical mechanical circuits which is M, then I have an electric mechanical resistance, then I have a two spring, one spring in here, another spring in here, connected here, and then this is applied a force in here. Okay. Now, let us this is R m, M, this is S1, this is S2. Draw the equivalent electrical circuits of the mechanical system given in figure 1 and find out the impedance, find out the mechanical resonance frequency of these circuits. So, if suppose is R m, S1, S2, S1 value I have given and M value I have given, then can you calculate the Zm? You have to calculate the omega 0, you have to draw the equivalent electrical circuits. So, what I said that a two spring, if the two springs are in parallel, it is equivalent to what is S effective? Two springs are parallel. If two springs are in series, 1 by S1 plus 1 by S2. If two spring is parallel, it is nothing but S1 plus S2. S1 plus S2, or you know that if two spring is in parallel, just before that I have so it is nothing but a S1 plus S2. So, I can replace these circuits by an equivalent mechanical circuits M, this is S effective, then there is a mechanical resistance and then a force is applied in here. Okay. Now, if this is the mechanical circuits, what is equivalent electrical circuits? I can easily draw it now. Now, it is your hand. Now, I can draw that volume velocity exists in here is u and here will be um, since it is not in grounded. So, I can say it is nothing but a force applied here and it produces a u. So, u is nothing but a resistance plus, so it is 1 by S equivalent and it is nothing but a R m, if it is R m, then there will be a inductance which is M, which is U. Okay. Now, can you find out the mechanical impedance of these circuits? Find out the mechanical impedance between this node and this node. So, you find out the equivalent impedance of these two things, equivalent impedance to do this thing and these two are in parallel. You can find to draw that things. So, what is the equivalent impedance is here? R m plus 1 by any capacitance, let us it is C1. So, it is j omega C1, these two are in series, this is let us Z1, then what is Z2? Z2 is nothing but a j omega L, let us this is nothing but a L. So, then this Z1 and Z2 are in parallel. So, Z1 let this is Z1 load Z1 and another load is Z2 is in parallel. Then I can find out the equivalent impedance if the two loads are parallel. Okay. Then I can find find out the resonance frequency of these circuits, either 1 by root over of LC or root over of S by S equivalent divided by mass. Okay. So, this way I can solve the problem. So, this kind of problem people may give you, that suppose there is a something that, okay, this is a diaphragm, the loudspeaker diaphragm, the mechanical impedance is given, mechanical resistance is given, stiffness of the diaphragm is given, mass of the diaphragm is given, and how it is housed, it is also given. So, you first draw the equivalent mechanical circuits, then you can convert to mechanical circuit to electrical circuits. Okay. So, that way you can do it. Now, suppose there is another problem. If you see the problem, just read the problem, this problem. If the intensity of a sound in air at 1 kilohertz is 12 watt per meter square, find out the value of root mean square pressure. Sorry, this is not in this chapter. Let us come to here. A mass of 0.5 kg hanging on a spring. The stiffness of the spring is given, the mechanical resistance is given, the force is given, of driving force is also given. What will be the steady state value of the speed amplitude and average power dissipation? Find the value of phase angle between the speed and force and resonance frequency. So, a mass of 0.5 kg, let us carefully read it. A mass of 0.5 kg hanging on a spring, the stiffness of the spring is given, mechanical resistance is given. So, first draw the mechanical circuits. So, a mass of hanging, so a spring will be there, a mass is hanging M, and with a mechanical resistance is given. So, Rm is equal to, what is the unit of Rm? Either kg per seconds or Newton meter per seconds, Newton second per meter. So, Rm is equal to 1.4 kg per second, Spring constant S is nothing but a 100 Newton per meter. What is mass? Mass is nothing but a 0.5 kg. And the applied force of this system F is nothing but a 2 cos 5 t. So, F is nothing but a F cos omega t. So, the value amplitude of the F is equal to 2 and omega is equal to 5. So, if this mechanical oscillation is in steady state, that means force oscillation at steady state. I have not considered the transitory part. So, that means the frequency of oscillation of the mechanical system is equivalent to the frequency of the force. Okay. So, what will be the steady state value of the speed amplitude and average power dissipation? What is the speed amplitude? Expression of a speed amplitude x. You know x. X is equal to, we have derived that, all the expression we have derived. You can know that expression. Okay. First, you have to find out the Zm. What is Zm? Zm is nothing but a Rm plus Jxm. So, what is mod Zm? What is the mod Zm? Mod Zm is nothing but a root over of Rm square plus Xm square. So, what is Xm again? Is nothing but a m omega minus s by omega. So, what is m? M is given, s is given, m is given, omega is given. I can find out Xm. So, Xm is nothing but a, what is m? 0.5 kg. Okay. So, 0.5 kg, let us calculate kg or gram, whatever, 0.5 kg into omega is given. What is omega? Omega is nothing but a 5. So, omega is given minus s is given 100 Newton per and omega is given. So, you can convert that unit and find out the value of Xm. Then you know Rm, find out the value of Zm. Okay. Now, what is the expression of Xm? What is the expression of Xm? X is nothing but a f by speed amplitude, f by omega Zm, real part, f by omega Zm sin omega t minus phi. Okay. So, I have to know the phi first. Phi is the angle between the, find the value of the phase angle between the speed and force and resonant frequency, value of resonant frequency and the phi I have to find out. What is the phi? Phi is nothing but a root over tan inverse Xm by Rm. So, you know the value of Xm, you know the value of Rm, you know the value of phi. Here you know the value of Zm, this is mod Zm value, you know the value of omega, you know the value of f. So, f is equal to 2, omega is equal to 5, Zm you can calculate, then omega you know, speed amplitude, this is the speed amplitude is only this one, f by omega mod Zm is the speed amplitude. Okay. Now, phi I can calculate easily, this is the phi. Then I can calculate power dissipation. What is the power equation? So, average power pi is nothing but a f square into Rm by 2 mod Zm square, 2 mod Zm square. So, if it is that, you know the value of mod Zm, you know the value of Rm, you know the value of f. So, you can calculate the average power dissipation. So, I can easily calculate everything. Okay. So, this problem is solved. Next, there is another problem. Consider a spring mass system described by equation 1. Give the value of k for which the system is underdamped, overdamped and critical damped. If the system is critically damped, find out the characteristics time of the system. So, what is given? Instead of circuits, they give an equation of the mechanical motion 2 d2x by dt square plus 3 dx dt plus kx is equal to 0. So, if you know that it is nothing but a m d2x by dt square plus Rm dx dt plus Sx or what is or Sx whatever S or K whatever you write is equal to 0. So, this S value I do not know. Okay. So, m is equal to 2, Rm is equal to 3. Find out the value of K or S whatever. Let us say write K here, K spring constant K. How do you find out the value of K? You know value of K for which the system is underdamped, overdamped and critically damped. Let us I consider for the critically damped condition. So, system will be critically damped if omega d, omega is equal to omega 0 or omega d is equal to omega 0. Okay. So, what is omega 0? Root over of k by m, root over of k by m. Find out the omega d value and then you can get that resonance things. Similarly, underdamped, overdamped you can calculate, find out the beta value and then equate the beta value. So, what is the beta value? Beta value is nothing but a Rm by 2m. So, Rm is nothing but a 3, 2 into m is nothing but a 2, 3 by 4. So, I said critically damped system will be critically damped if beta is equal to omega 0. So, this is equal to beta. So, root over of k by m is equal to 3 by 4 or k by m is equal to 9 by 16. So, m is 2. So, I can find out the value of k. Similarly, tau, what is tau? It is nothing but a 1 by, tau is nothing but a 1 by beta. So, it is beta is 3 by 4. So, tau is 4 by 3. So, 1 point something second. Okay. So, easily you can calculate. So, tractor I have given, this is not yours. Then, okay. So, any mechanical oscillation something is given, you can do that things. Let us I say that somebody is riding in a motorcycle and there is a bump, consecutive bump and separated by some things, and again say tractor problem can be given, okay, and equation of motion will be given, beta, find out the critical damping, find out the spring constant. Similarly, draw the mechanical equivalent mechanical circuits. I give you one problem. I will not do it. You just try to do it. I describe the problem. Suppose that you want to install a chiller plant or AC for AC chiller plant with a foundation engineering. Suppose I have a chiller plant of mass is given, mass of the chiller plant is given. To install in the earth using a spring, okay, using spring, 4 spring at 4 corner, and I installed it. Okay. Can I find out the resonance frequency of that system? Can we draw the equivalent mechanical circuits of that system? Can I find out that all the other characteristics of mechanical motion? So, you see that problem will be not given as a bookish problem. Practical problem will be given, let us say people will say I have a chiller plant, I want to install with a rubber pad, and rubber pads spring constant and mechanical resistance is given, let specification is given. Then are this installation is correct or not, or is it vibrate? That means, if I know the vibration frequency, or suppose that once I chiller plant is on, so force will be applied, and that force frequency I know, if that frequency is resonate with that your system frequency, then what will happen? Chiller plant cannot be stable. So, I have to operate the operation frequency of the chiller plant, so below the resonance frequency, or if I know the applied maximum applied force frequency, then I can find out, okay, my resonance frequency should be well above of these things. Okay. Similarly, given a practical problem, suppose I want to design a loudspeaker, okay, loudspeaker I want to design. I know the diaphragm mechanical circuits. So, I know the diaphragm resonance frequency omega 0. Now, if I want to operate this loudspeaker with 20 hertz to less 10 kilohertz, then my omega 0 should be much above the 10 kilohertz, so that resonance is not happened. If the resonance is happened, then gone. Okay. So, I can easily calculate, if I know the mechanical things, I can easily draw the equivalent or mechanical circuits and find out the impedance, find out the resonance frequency, and I know the operation frequency. So, I say, okay, resonance frequency is this. So, it will. So, I will choose the mass of the diaphragm, stiffness of the diaphragm, and that things depending on that design requirement. Okay. Thank you.